In the demo I just showed you, we had a bunch of objects that we were able to divide into two groups. With one group of objects, every object in the group fell exactly the same way as every other object in the group. That group of objects included the tennis ball, chalkboard eraser, the tape dispenser, the crumpled piece of paper, and the deck of playing cards. Objects in the other group each fell differently than every other object that we saw in the video. Right? The balloon, the coffee filter, the flat piece of paper, the thin strip of paper, each of these objects fell differently from all of the other objects in that group, and also all of the objects in this group as well. Our question now is this: what properties of an object tend to put the object in the, quote, same group, and what properties of an object tend to put the object in the, quote, different group? Have you noticed that objects which end up in the same group over here tend to be heavier and more compact? Objects which fall differently from each other tend to be lighter and have greater surface areas. So why is it that objects which are heavier and more compact tend to all fall exactly the same way, and objects which are lighter and have greater surface areas tend to all fall differently from each other? When an object falls through the air, two forces act on the object. So let's say this is an object falling through the air. There will be two forces acting on the object. We have the gravitational force pointing down, and then also a drag force pointing up. The drag force is also known as air resistance in this context. The drag force always points opposite of the motion of the object through the medium. So if the object is falling downward through the air, the drag force will point up. So here's what determines whether an object ends up in the, quote, same group that we discussed here, or in the, quote, different group. First, let's consider an object that feels only a gravitational force. Objects which experience only a gravitational force, but no drag force, all fall in exactly the same way. Objects experiencing only the gravitational force all fall in exactly the same way as each other. This type of motion is called free fall motion. Free fall motion is motion in which gravity is the only force acting. Any two objects which are free falling will fall in exactly the same way as each other, provided that they started out with the same initial motion. In reality, none of the objects that I showed you in the demo were actually free falling. Any object I showed you in the demo was moving through air, and any object moving through air will always experience at least a little bit of air resistance. So let's consider objects in that category, objects which are experiencing a tiny amount of air resistance. So for our second possibility. Let's consider an object which experiences a gravitational force, of course, but also experiences a drag force which is teeny tiny in comparison to the gravitational force. If an object experiences a drag force which is teeny tiny in comparison to the gravitational force, the motion might still be close enough to free fall motion that we can't tell the difference. Okay, so if objects in the quote same group from the demonstration fit this description. Objects in that same group from the demonstration feel drag forces which are very small in comparison to the gravitational force. And because of that, all of those objects tend to fall in a way that matches each other, because all of these objects are falling in a way which is pretty close to being free fall motion. Finally, let's talk about those objects which fall into the quote different category. So objects in the different category experience a gravitational force, but they feel a drag force which is not so small compared to the gravitational force. Once the drag force gets to be where it is no longer so small compared to the gravitational force, the drag force can start affecting the motion of the object as it falls. The thing about a drag force is that different objects are going to experience different drag forces according to their size and shape. So those different objects are going to be affected differently by those different drag forces, and so all of those falling motions are going to be different. Okay, so to sum up, the drag force will act differently on objects with different shapes and sizes. So once you get to objects which are feeling drag forces which are substantially big in comparison to the gravitational force, those objects are going to fall differently from other objects experiencing substantial drag forces, and they will fall differently than free-falling objects or objects which are close to free-falling. In this class, we're going to neglect drag forces and concentrate on studying objects which are free-falling, which is to say they are acted on only by the gravitational force. What we have not yet discussed in this class is what a free-falling object is actually doing after you have set it into motion. So in the next video, we're going to see what is a free-falling object near the Earth's surface actually doing.